Welcome to this explainer. Today, we're zooming out. We're looking at something way bigger than just a subject you took back in school. We're framing science as a literal, truth-seeking mission. In a noisy world that is absolutely overflowing with information, learning how to actually think like a scientist is honestly one of the most powerful tools you can have to navigate reality. I want to hook you right away with this scripture. Test everything, hold fast what is good. This brilliantly sets the whole theme for our explainer today. Because science isn't just about microscopes and lab coats, right? It's deeply connected to this fundamental human mandate to separate fact from rumor, to question what we hear, and to relentlessly validate information so we can hold on to what is actually true. Okay, let's dive into this. Here's our roadmap so you know exactly where we're headed. We'll cover the quest for truth, observations and inferences, writing testable hypotheses, the power of theories, test your thinking, and finally, education paired with morality. Let's build that scientific toolkit. All right, starting with section 1, the quest for truth. You see, the scientific way of thinking totally isn't confined to a laboratory. It's really a mental framework that helps you evaluate those news articles you scroll past, solve complex everyday problems, and make major personal decisions with crystal clarity. Science basically helps you separate fact from opinion and truth from rumor. It's fundamentally a way of knowing about the world. It's this deliberate process of asking questions, collecting solid evidence, and building explanations. And ultimately, mastering this process makes you a vastly sharper thinker no matter what situation you find yourself in. Moving right along to section 2, observations and inferences. To think scientifically, we really have to start with the most basic building blocks of how we interact with reality. We need to clearly separate how we look at the world from how we interpret what we see. So first, let's look at the definition of an observation. An observation is undeniable raw data collected directly from reality. It relies entirely on facts you can detect using your physical senses or scientific tools. For example, stating the leaves on the plant are yellow is an observation. It's a fact. It's right there in front of you. Now, compare that to an inference. An inference is a possible explanation for what you just observed. It's the logical guess, or kind of the mental leap we make to explain those raw facts. So, taking our yellow leaves, an inference would be the plant might not be getting enough nitrogen. We don't know that for a fact yet, but it's a logical attempt to explain what we observed. And this brilliantly illustrates the difference in a real-world scenario. Let's say your observation is, there is water on the outside of my cup. You see it, you can physically touch it. Your inference might be, the cup is leaking. This is seeing versus guessing. And why does this matter? Well, because your inference could be totally wrong. The water is highly likely just condensation from the air, not a leak in the cup at all. Confusing an inference with an observation can cause some serious problems. If you treat a guess, an inference, like a hard fact, you might throw away a perfectly good cup. Or worse, in real life, make terrible decisions based on assumptions you mistakenly thought were undeniable facts. Which brings us to section 3, writing testable hypotheses. This is where we explore how we take those logical guesses and actually put them to the test out in the real world. Let's see how this builds our ladder of scientific inquiry. It's a totally natural progression. Step 1, you make an observation. Step 2, you formulate an inference to explain it. And step 3, you take that inference and shape it into a formal hypothesis. So what exactly is a hypothesis? Well, by definition, it's a testable statement that predicts what will happen in an experiment. I really want to emphasize the absolutely crucial word here, testable. A hypothesis isn't just a random thought. It's worded in a very specific way so that you can actively design an experiment to find out if it's actually true. Let's look at this transition in action using a bean plant. We start with a vague question. Does sunlight make beans grow taller? To make this work scientifically, we have to make it measurable and specific. So our hypothesis becomes, if bean plants get more hours of sunlight each day, then they will grow taller over 2 weeks. Boom, we have specific variables, a time frame, and a condition we can perfectly measure. All right, section 4, the power of theories. When hypotheses are tested over and over again, we reach the highest level of the scientific ladder. But first, we really need to completely dispel some common everyday myths. In science, a theory is a well-tested, widely accepted explanation for how something works. When you hear someone say, oh, that's just a theory, they are actually using the word incorrectly. It is absolutely not just a guess.
when a ton of experiments by different scientists lead to the exact same conclusion, they support a theory. And what's fascinating is that theories can change if new evidence appears, but that adaptability is exactly what makes them stronger and more reliable over time.
To truly grasp the massive explanatory power of a theory, consider plate tectonics. It's classified as a theory because it is robust enough to connect and explain multiple, seemingly totally unrelated phenomena, like why earthquakes happen, why volcanoes erupt, and how entire mountain ranges are built, all using diverse, hard evidence like rock layers, GPS data, and seismic waves. It's like a giant puzzle coming together.
Let's move to Section 5, Test Your Thinking.
Now I'm going to challenge you to become a detective for a second. We are going to actively apply the toolkit we've just built together. Let's see how sharp your thinking has become. Can you write 2 observations and 1 inference about a melting ice cube? Try to mentally separate them right now. Your undeniable facts, your observations, might be there is a puddle of water forming and the solid shape is getting smaller. Your inference, your logical guess to explain it, might be the temperature of the room is warmer than freezing. See the difference? Here's another one. How do you turn the vague phrase, bigger seeds grow better, into a testable hypothesis? Think about adding specific, measurable variables. You might say, if I plant seeds that are 5 millimeters wide compared to seeds that are 2 millimeters wide, then the larger seeds will produce sprouts that are taller after 10 days. Now you have something you can actually go out and test in the dirt. Okay, let's try one more. The sky is red. Smoke from a wildfire must be present. Which part is which? I'm sure you nailed it. The sky is red is the raw observation you literally see with your eyes. Smoke from a wildfire must be present is the inference. It's your logical explanation for why the sky is red. And finally, Section 6, Education paired with morality.
We've built an incredible set of scientific tools today, but we must understand a crucial philosophical foundation. Education without morality will hurt. The heroesmartacademy purposefully intertwines biblical morality with education because having scientific tools and critical thinking skills requires a really strong ethical grounding to be truly beneficial to yourself and the world around you.
And this beautifully connects to Romans 8, 6-7, which promises peace of mind to everyone who keeps their mind spiritual. The pursuit of truth in science isn't just a cold academic exercise. When it's guided by a spiritually grounded mind, it brings a profound sense of peace and stability to your life experience. I want to conclude our explainer today with this powerful, provocative thought. What is the point of being smart and supposedly educated if you continue to make bad choices that hurt? It leaves us to reflect on the ultimate purpose of our learning. We sharpen our minds with the tools of science, yes, for sure, but we must guide those sharp minds with the compass of morality. Thank you so much for joining me, and keep testing everything to hold fast to what is good.